Welcome to new lecture on energy efficiency strategies for new buildings and existing buildings, where we explore the latest trends and strategies in the world of energy efficiency. I am your host Ibdit Kaur Bhatia, and today we are diving into the key insights and best practices from successful energy efficiency projects. Whether you are a project manager, an energy professional, or simply interested in how to make our world more sustainable, you won't want to miss this. In this lecture on energy efficient buildings, we will cover case studies and best practices and also lessons learned from successful projects. We will begin by looking at key insights and best practices from successful projects. Then we will discuss some challenges faced and strategies for overcoming them. Finally, we will see recommendation for future energy efficient building projects. Now, in the introduction part, we will cover various aspects of energy efficient buildings, which refers to a structure designed and constructed to minimize energy consumption for heating, cooling, ventilation, lighting and other operational needs. These buildings incorporate energy saving design features, technologies and practices to reduce their environmental impact and operating costs. Now, importance of energy efficient buildings. First, reduce energy consumption, lower utility bills, energy efficient features like insulation, efficient HVAC systems and LED lighting can significantly reduce energy consumption, leading to lower utility costs. Increased affordability. By reducing energy expenses, energy efficient buildings can be more affordable for occupants, both residential and commercial. Lower carbon footprint. Now, reduced greenhouse gas emissions. By consuming less energy, energy efficient buildings contribute to a lower carbon footprint, helping to mitigate climate change. Second, environmental sustainability. These buildings align with sustainable practices, promoting a healthier planet for future generations. Cost savings. Long-term financial benefits. While initial investments in energy efficient features may be higher, the long-term savings from reduced energy consumption often outweigh these costs. Increased property value. Energy efficient buildings are generally more attractive to buyers and tenants, potentially increasing their property value. Improved indoor air quality. Healthier environment. Energy efficient features like proper ventilation and reduced air leakage can improve indoor air quality, leading to a healthier living or working environment. Reduced health risks. Better indoor air quality can help reduce the risk of respiratory problems and other health issues. Increased comfort. Optimized temperature control. Energy efficient systems can provide more precise temperature control, ensuring comfortable indoor environments throughout the year. Reduced noise pollution. Well insulated buildings can help reduce noise pollution, creating a quieter and more peaceful atmosphere. Now, coming to the part key insights of energy efficiency buildings. Energy efficiency buildings key insights are clear objectives and scope. Successful energy efficiency projects start with clear defined goals. Strong leadership and governance. Effective leadership and a robust governance structure are vital. Leaders should guide the project, make strategic decisions and ensure the team stays aligned with the project's goal. Detailed planning and risk management. Detailed planning is essential. This includes not only the technical aspects but also budgeting, timelines and resource allocation, identifying potential risks and developing strategies to mitigate them ensures smoother project execution. Effective communication. Open and transparent communication is key. Regular updates and feedback loops keep all stakeholders informed and engaged, helping to address issues before they become major problems. Stakeholder engagement. Involving stakeholders early and throughout the project helps in understanding their needs and gaining their support. This can lead to smoother implementation and better acceptance of energy efficiency measures. Also, some more technologies for energy efficient building strategies. These comprises of number 1, comprehensive energy analysis. Under comprehensive energy analysis, conduct through thorough energy audits to identify areas for improvement, utilize energy modeling software for simulations and predictions. Second, energy efficient building envelope. Optimize insulation and air sealing to minimize heat transfer. Select high performance windows and doors. Consider passive solar design strategies. Third, sustainable HVAC systems. Install efficient HVAC equipment, example heat pumps, geothermal systems. Implement demand control ventilation and occupancy sensors. Next, renewable energy integration. Explore solar photovoltaic systems, that is the PV systems, wind turbines or biomass energy generators. Consider energy storage solution, example batteries. Smart building technologies. Utilize building automation system BAS to control energy consumption. Implement energy management strategies and demand response programs. Now, what are the best practices? Coming to the best practices, design for energy efficiency. Integrate energy saving features from the initial design phase. Prioritize natural lighting and ventilation. Consider the building's orientation and shading. Second, material selection. Choose energy efficient materials, example low emissivity glass, recycled content. Then evaluate embodied carbon emissions. Third, commissioning and verification. Ensure proper installation and operation of energy efficient systems. Conduct post occupancy evaluations to verify performance. Then ongoing maintenance and monitoring. Regularly maintain and calibrate equipment, monitor energy consumption and identify areas for improvement. Implement energy saving behaviors among building occupants. Now, case study of a successful energy efficient building project. Case study 1, the Mahindra World City in Chennai, a sustainable Indian landmark. The Mahindra World City in Chennai, India is a prime example of a successful energy efficient building project in the Indian context. This sprawling industrial park has incorporated a range of sustainable strategies and technologies to minimize its environmental impact and reduce operating costs. Now, what are the key strategies and technologies employed? Coming to the key strategies, integrated energy management. The project has implemented a comprehensive energy management system to monitor and optimize energy consumption across various facilities. Renewable energy integration. Solar power plants have been installed within the industrial park to generate clean energy and reduce reliance on the grid. Energy efficient infrastructure. Buildings within the city are designed with energy efficient features such as a high performance insulation, efficient lighting system and natural ventilation. Green building certification. Many buildings within the Mahindra World City have achieved green building certification like LED or IGBC, ensuring compliance with sustainable design standards. Water conservation. Rainwater harvesting systems and efficient water usage practices have been implemented to reduce water consumption. Waste management. The industrial park has implemented waste management strategies to minimize waste generation and promote recycling. Now, what are the achieved energy savings and environmental benefits? Through this building, what we have achieved? Significant energy reduction. The Mahindra World City has achieved substantial energy savings through its sustainable initiatives reducing its carbon footprint and operating costs. Renewable energy generation. The solar power plants have generated a significant amount of clean energy, contributing to India's renewable energy goals. Improved water efficiency. Water conservation measures have helped to reduce water consumption and protect local water resources. Enhanced environmental sustainability. The project has demonstrated that it is possible to develop large-scale industrial parks while minimizing environmental impact. Economic benefits. The Mahindra World City has created jobs and stimulated economic growth in the region, demonstrating the economic viability of sustainable development. The Mahindra World City in Chennai showcases the potential for sustainable development in India. By adopting energy efficient strategies and technologies, the project has set a precedent for other industrial parks and urban developments in the country. Challenges faced by Mahindra World City in Chennai for energy efficiency. What are the challenges? The Mahindra World City in Chennai, despite its successful implementation of energy efficient strategies, has also encountered several challenges. Here are some key obstacles. Economic constraints. Initial investment. The upfront cost of implementing energy efficient infrastructure can be significant, especially for large scale projects like the Mahindra World City. Payback period. While energy efficient measures can lead to long term cost savings, the payback period can be lengthy, making it difficult to justify the initial investment. Technological limitations. Emerging technologies. Some energy efficient technologies may still be in their earlier stages of development, limiting their availability and affordability. Integration. Integrating different energy efficient systems and technologies can be challenging, especially in large scale projects. Regulatory barriers. Building codes. Building codes and regulations may not adequately support energy efficient design and construction practices, hindering the implementation of innovative solutions. Permitting process. Obtaining necessary permits and approval for energy efficient projects can be time consuming and bureaucratic. Site specific constraints. Existing infrastructure. Retrofitting existing buildings and infrastructure within the Mahindra World City to make them more energy efficient can be difficult and costly. Climate and location. The specific climate and location of the Mahindra World City can influence the most effective energy efficient strategies. Human resource challenges. Skilled workforce. Finding and retaining skilled professionals with expertise in energy efficiency and sustainable development can be challenging. Training and education. Providing adequate training and education to employees on energy efficient practices can be time consuming and costly. Supply chain challenges. Availability of materials. Ensuring the availability of high quality energy efficient materials and equipments can be difficult, especially in emerging markets. Cost fluctuations. Fluctuations in the cost of energy efficient materials and technologies can impact project budgets. Despite these challenges, the Mahindra World City has demonstrated the potential for sustainable development in India. By addressing these obstacles and continuing to invest in energy efficient practices, the project can serve as a model for other industrial parks and urban developments in the country. Now coming to the case study 2, the Indira Paryavaran Bhavan, New Delhi. A successful energy efficient building project in the Indian context is the Indira Paryavaran Bhavan in New Delhi. It is one of the most energy efficient office buildings in India and serves as the headquarters for the Ministry of Environment, Forest and Climate Change. Here's a detailed look at its key strategies, technologies, energy savings and environmental benefits. Coming to the key strategies and technologies employed. First is the passive design strategies. Already we have discussed in the earlier lectures that how passive design strategies like building orientation and design, the building is oriented to minimize the heat gain and optimize natural daylight. It has a north-south orientation to reduce direct solar heat gain, while shaded courtyards and green roofs help keeping the building cool. Second, high performance building envelope. The building uses double glazed, low emissivity, low E windows and insulated walls to reduce heat transfer, thereby reducing the need for air conditioning. Next, natural ventilation. The design incorporates cross ventilation to maintain airflow and reduce the reliance on mechanical cooling. Energy efficient HVAC systems. Second part, chilled beam technology. The building uses as advanced heating, ventilation and air conditioning, that is HVAC system, with chilled beams that provide cooling without fans, reducing energy consumption by up to 50% compared to conventional HVAC systems. Variable air volume VAV system. A VAV system is used to ensure that only the necessary amount of conditioned air is supplied to different zones, optimizing energy use. Renewable energy integration, the third part. Under renewable energy integration, solar voltaic panels. The rooftop is equipped with solar panels that generate about 90 kilowatt of electricity, contributing significantly to the building's energy requirements. Next, solar water heating systems. Solar heaters provide hot water for the building, further reducing energy consumption. Fourth part, energy efficient lighting. Now LED lighting and with occupancy sensors. The building uses LED lighting throughout and incorporates occupancy sensors and daylight sensors to minimize energy consumption. Next, daylight integration. Skylights, clerestory windows and light shelves are used to bring in natural light, reducing the dependence on artificial lighting during the day. Fifth, water and waste management. Under water and waste management comes rainwater harvesting and wastewater cycling. The building has a rainwater harvesting system and a sewage treatment plant for recycling grey water, which is used for landscaping and cooling towers. Low floor fixtures. Water efficient fixtures are installed to minimize water usage. Achieved energy saving and environmental benefits. Now, what are the energy savings achieved through this building? Is energy savings. Indira Paryavaran Bhavan is a net zero energy building, NZEB, meaning it produces as much energy as it consumes. It achieves energy savings of around 60% compared to a conventional building of smaller size and function. Reduction in carbon emissions. The building's energy efficient strategies and renewable energy integration has resulted in a significant reduction in carbon emissions, helping mitigate climate change impacts. Next, water savings. Through rainwater harvesting, water wastewater cycling and low flow fixtures, the building achieves substantial water savings, addressing the issue of water scarcity in urban areas. LEED Platinum certification. The building is certified as LEED Platinum by the US Green Building Council, recognizing its high performance in energy efficiency, water conservation and sustainable building practices. Now the challenges. What are the challenges? Initial investment and maintenance costs. While the building is designed to be energy efficient, the initial investment in advanced technologies, renewable energy system and sustainable materials is high. Maintaining these systems such as photovoltaic panels, solar thermal systems and green roofs can also be costly and requires specialized knowledge and regular upkeep. Second, system integration and management. integrating different energy efficient systems like HVAC, heating, ventilation and air conditioning, lighting and water management systems requires a sophisticated building management system, that is the BMS, ensuring that these systems work harmoniously and effectively can be challenging and requires continuous monitoring and optimization. Performance degradation over the time. The performance of energy efficient technologies such as solar panels and HVAC system can degrade over time due to the wear and tear, dust accumulation and climatic conditions. Maintaining peak performance levels requires regular inspections, cleaning and possibly retrofitting or replacing components. Now, fifth point is the dependence on weather conditions. The building's energy efficiency heavily depends on New Delhi's weather conditions. During extremely hot summers or cold winters, the building energy demand for heating and cooling can rise significantly, potentially reducing overall energy savings. Sixth, data management and analysis. Effective energy management requires the collection, analysis and interpretation of large amounts of data from various sensors and systems within the building. This requires sophisticated data analytics tools and expertise to identify inefficiencies, predict maintenance needs and optimize energy use. Seventh, adapting to new technologies. As energy efficient technologies continue to evolve, there may be a need to upgrade or replace existing systems to incorporate new innovations. This can be both a financial and logistical challenge, especially in a government building where budget constraints and bureaucratic processes can delay implementation. Eighth, grid dependence and renewable energy integration. While the building integrates renewable energy sources such as solar panels, achieving a balance between grid dependence and renewable energy use can be challenging. Issues like intermittency, storage and the efficiency of the renewable energy system can impact overall energy efficiency. Conclusion. Indira Paryavaran Bhavan serves as a model for sustainable building practices in India. Its successful implementation on energy efficient technologies and strategies demonstrates the potential for substantial energy savings, reduced environmental impact and sustainable development in urban settings. This project is an excellent example of how green buildings can be designed and operated effectively in the Indian context. Now, what are the challenges faced and strategies for overcoming them? The challenges of energy efficient building design. While there are a number of benefits to thermally efficient building design, realizing them can be challenging. Architects must overcome logistic issues, material costs and restrictive building codes to design a high performance building that meets or exceeds energy efficiency standards. The following challenges can complicate your design process, so be sure to consider them in the early stages of planning. First, education. While our clients are familiar with wood, steel, concrete and glass materials, some are not as familiar with new thermally efficient materials such as insulated concrete forms, ICF, which is concrete sandwiched between layers of polystyrene foam, is used to increase the R value of the wall assembly. Second, environmental conditions. Site climate has a massive impact on energy efficient building design. In areas where the temperature is especially warm or cold, most of the year, the right material must be used to combat the effects of the climate on the building. Daylighting is also always a factor. The cost of labor and materials. Not only do you have to consider the types of materials that will be ideal for the climate and for occupant comfort, but you will also need to factor in the cost of materials and the effort required installing them. For example, wood is currently relatively affordable compared to the cost of steel, but wood framing may take longer to construct than steel framing. However, Steel absorbs and releases heat more quickly than wood, making it less efficient overall in warm regions. So you will need to weigh the benefits and challenges of each. Next, federal, state and local codes. Government agency rules may limit the types of materials that can be used in building design. For example, architects building schools in California must follow very strict guidelines. Also in that state, new buildings are required to meet Title 24 standards. Coming to the recommendation for future energy efficiency building project. Policies and regulatory framework for energy efficient buildings. Strengthen building codes. Mandate energy performance standards, prospective and performance based codes and regular updates. Then tax incentives and subsidies. Investment credits, property tax exemptions, loan programs, green building certification program, third party verification, leadership in energy and environmental design, that is the LEED, incentives for certified buildings. Coming to the technological advancement in energy efficient buildings. Research and development, continuous innovation, invest in research and development to advance energy efficient technologies such as new materials, building systems and renewable energy sources. Collaborative efforts, foster collaboration between industry, academia and government to accelerate technological process. Focus on emerging technologies. Prioritize energy research and development in areas with high potential for energy savings such as building automation, energy storage and advanced materials. Integrating and interoperability. Standardization, that is the develop and promote standards for energy efficient technologies and their integration into building systems. Interoperability ensures that different energy efficient components and systems can communicate and work together effectively. Building automation system BAS. Utilize advanced BAS to optimize energy consumption and control various building functions. Smart building technologies. Under the smart building technologies, energy management systems. Implement energy management systems that monitor and control energy use in real time. Demand response. Participate in demand response programs to reduce energy consumption during peak demand periods. Internet of Things IoT. Leverage IoT devices to collect data on energy usage, occupancy and environmental conditions for more efficient building management. Artificial intelligence AI. Apply AI algorithms to optimize energy consumption, predict maintenance needs and improve building performance. Education and training for energy efficient buildings. Curriculum development. Integration into education. Incorporate energy efficient into the curricula of architecture, engineering and construction management programs. Specialized courses. Develop specialized courses and training programs focused on energy efficient building design, construction and operation. Continuous professional development. Offer continuing education opportunities for building professionals to stay updated on the latest advancement in energy efficiency. Training programs. Hands-on expertise. Provide hand-on training and workshops that allow participants to learn about the energy efficient technologies and practices. Case studies. Use case studies to illustrate real-world example of successful integration energy efficient projects. Certification programs. Establish certification programs for building professionals specializing in energy efficiency to recognize their expertise and credibility. Public awareness campaigns. Targeted messaging. Develop targeted messaging campaigns to reach different audiences including building owners, occupants, policymakers and the general public. Social media and digital marketing. Utilize social media and digital marketing channels to disseminate information and engage with stakeholders. Partnership with influencers. Collaborate with influencers and industry leaders to promote energy efficiency and raise awareness. Collaboration and partnership for energy efficient buildings. Public-private partnership. Shared goals. Collaborate with government agencies, industry associations and research institutions to achieve common goals in energy efficiency. Resource sharing. Pool resources, expertise and funding to support energy efficient building projects and initiatives. Policy development. Work together to develop and implement effective policies and regulations that promote energy efficiency. International cooperation. Knowledge exchange. Share best practices, research findings and technological advancement related to energy efficiency on a global scale. Joint projects. Collaborate on international projects to address common energy efficiency challenges and develop innovative solutions. Global standards. Promote the development and adoption of international standards for energy efficient buildings. Other techniques used in building for increasing energy efficiency of buildings, which we have already discussed in the previous lectures, here is a brief of them. First, solar photovoltaic PVs. Key factor influencing solar energy capacity includes spacing, shading and local solar insolation. PV panel costs have significantly reduced in recent years, making the sustainable solution more accessible to businesses. Second, solar water heater. Third, geothermal heat pumps. Fourth, wind turbines. Fifth, biomass energy. Sixth, hydrokinetics. Seventh, embrace passive design principles. One of the fundamental strategies in energy efficient building is passive design. This involves using the building's orientation, shape and materials to maximize natural light, heat and cooling. Under this comes orientation, insulation and thermal mass, natural ventilation. Eighth, invest in energy efficient windows and doors. Already we have discussed that windows and doors are critical components of a building's thermal envelope. Investing in high performance options can significantly impact energy consumption. Under this, double glaze or triple glazing, glow e-coatings, insulated frames. 9. Incorporate renewable energy sources. Integrating renewable energy sources into building design can significantly reduce reliance on non-renewable power and decrease operational costs. Under this, solar panels, solar thermal systems, geothermal heat pumps. 10th, focus on energy efficient lighting and HVAC system. Lighting and heating, ventilation and air conditioning HVAC systems are major energy consumers in buildings. Under this comes the LED lighting, smart controls, high efficiency HVAC system. 11th, utilize smart building technologies. Smart building technologies enhance energy efficiency by optimizing the operation of various systems through automation and data analysis. Building management system BMS and energy management system EMS are the major important part of this, and smart meters. Now 12th part is the prioritize sustainable materials and construction practices. The choice of materials and construction methods can greatly influence the energy efficiency and environmental impact of a building. Under this, sustainable materials, green certifications, construction waste management. 13th, design for adaptability and future trends. Buildings should be designed with adaptability in mind to accommodate future changes and advancement in technology like flexible spaces and future proofing. Now in conclusion, the future energy efficient building projects should focus on a combination of passive design principles, advanced technologies and sustainable practices. By integrating these recommendations, we can create buildings that not only reduce energy consumption but also contribute to a more sustainable and resilient future. In the next lecture, we will cover various topics like overcoming implementation challenges in energy efficient buildings, common challenges in implementing energy efficient practices, strategies for addressing technical, financial and organizational barriers, case studies illustrating successful solution to implementation challenges. Thank you for your kind attention everyone.